This is number 15 from the end of chapter 3, AP practice questions. This one is a very common type of question and is very conceptual. So pay close attention to what I'm doing. I'm going to graph these points. So they give us 4 points. And my graph will not be accurate. I'm doing this graph just to give you a kind of an idea of what's happening. So our first point is 1, negative 2.8. So roughly, I'm going to guess it's there. Our next point is 1.001, negative 2.805. Now, like I said, it's not going to be accurate, but I'm going to say, you know what? It's right there. And then our next point, I'm going to say is right there. My last point, I'm going to say it's right there. Now, this is not to scale. Okay, this is for conceptually what's going on. Now, what do they want? I think I chopped off what they wanted, but the question asked, this is sad, I chopped it up. They want you to approximate f prime of 1. I think I spelled that wrong. Approximate f prime at 1. Does that have 2 p's in it? I think it does. Let me throw one in there. So how do you do that? You don't have the function, so you can't take the derivative, so you can't find f prime at 1, but conceptually, you should know f prime of 1 is the slope of the tangent line. So we have some kind of a curve going on here. And I have a tangent line at 1. So I want to find the slope of that red line. But how do I approximate that? All I have are, whoa, it's dancing. The dancing tangent line. Let me move this slightly. What's it doing? I don't understand. There we go. So how do I approximate it when I'm given 4 points? I have those 4 points. So how do I use that? So concepts you need to know. The slope of this line is dy dx, which is rise over run at a specific point. It's the derivative gives us the slope of that red line. So here's the concept. That is also called the instantaneous rate of change. If you can read that. So it's how fast y is changing compared to x at a specific point. Here's what you're able to do. I could find the slope of that yellow line. The slope of that is the average rate of change, which is delta y over delta x. But how do you find delta y over delta x? Well, you've been doing that this whole chapter. Average rate of change is f of b minus f of a over b minus a. So the slope of that line will be, excuse me, f at 1.001 minus f at 1 over 1.001 minus 1. It's f of b minus f a or b minus a, average rate of change or the slope of the secant line. That will be negative 2.805 minus negative 2.8 all over 0.001, which is, that becomes plus positive. It's going to be negative 0.005 over 0.001. Multiply top and bottom by 1,000. You get negative 5. Whoa, what just happened? Negative 5 is the approximate slope of the tangent line. So what's happening? You could look at that and say, hey, that slope is pretty close to that slope. So I'm going to use the slope of this yellow line to approximate. Like I said, this is a common question on FRQs on the AP test. Now, some might say, why use those 2 points? I choose to use these 2 points. Could you use those 2 points to approximate? The answer is yes, but which one's closer? Obviously, the 2 points closer give a better approximation to that red slope. Okay, so you could use average rate of change between any of those points to approximate, but you want the one that's closest. So we choose the 2 points near it.